This is Geometry Unit 7, Lesson 1 on Basic Constructions. Constructions are using the rules for geometry, segments and angles, to create different shapes without having to use measurement. So, when you have a construction, you have to have a compass and a straight edge. We're not going to use the straight edge as a ruler. We're not measuring. We are going to use the compass to figure out our measures. Now, why constructions work are for these reasons. You can draw a line segment may be drawn between any 2 points. That's true. A line segment can be extended indefinitely in either direction. You can make a line segment as long or as short as you want. Radii of the same circle or arc are congruent. So no matter where you draw a radius on a circle, it's going to be the same. And if you draw an arc also. And if you draw radii of congruent circles, they're also going to be congruent. So using these facts about constructions, we can actually do our basic constructions and use them to draw other things. The first basic construction that we're going to do is we're going to construct segment CD that is congruent to AB in the direction of P. What we're going to do is we are going to copy this segment AB. It's going to be exactly the same length. We're going to name it CD, and it's going to be going in the direction of P. So, first of all, I need a segment to work with. I know that it's got to go in the direction of P, so I'm going to get out my ruler, use your ruler, and draw a segment from C to P, because that'll be the direction I want to go. Now, the end point of my segment C, I want it to be congruent to the segment A. It's going to correspond to A. So I need to know the distance from A to B. To measure distance, I have to use my compass. Here's my compass. So if I put my compass on the end point of A, I'm going to turn my compass around here, and then I open my compass until the pencil part, in my case it's a pen, is on B. And then I make a little hatch mark. The little hatch mark shows that I have measured the segment. So the segment is that wide with the compass. So since A corresponds to C, I'm going to move my compass over here without changing the width. And I'm going to make a little hatch mark without changing the width. I got to keep this on 200. Oops, where am I? 200. There, right there. And then make my little hatch mark here. So the distance from here to here is the same as the distance from here to here. So we have just created the endpoint D. So this segment CD is congruent to AB. So that is copying a segment. AB is congruent to CD because the width of the compass would actually be like a radius of a circle. It's going to be the same everywhere. The second construction that we're going to do is copying an angle. I'm going to construct angle B that is congruent to angle A with one side on ray BP. So I want to copy the measure of this angle over here so that BP is one side of the angle. So first thing I need to know, I know that this ray right here is the flat side, so I'm going to make this side the flat side as well. I need to know how far angle A opens. So to measure how far angle A opens, I have to figure out a place to measure it. So what you need to do is take your compass and put your point on A. You turn my compass around, put your point on A. Then you want to see where the compass is going to open. Now where it opens depends on where you put your compass. So just somewhere, open your compass, make sure your point is on A, and then draw an arc that touches both sides of the angle, like so. Once you do that, you do exactly the same thing with your endpoint on A. Move your compass over here without changing it. Do exactly the same thing here. Draw an arc. All right, so that arc is exactly the same place on both of the figures. So A is corresponding to B. I drew the same arc. Now, take your compass on one of the rays where you intersected with the arc that you just drew, put your point, and put your pencil part over here and measure that opening. That tells how far the angle opened. And make a little hatch mark there to show that you measured it. And then come over here and do exactly the same thing. All right, my point is on here just like it was over here. And then I make my little X right here. And when I have created this X, I want to connect my endpoint B here through the X, and I have created the same angle. So B and then it has to go through the x, and then angle A is congruent to angle B. This angle measure is exactly the same as this angle measure. If you got a protractor out and measured this, these angles would be exactly the same. That's the second basic construction. The third basic construction is constructing the perpendicular bisector of AB. Now AB, the perpendicular bisector, is a line that goes exactly down the middle of the segment. Now remember that it has to be equidistant from each of the endpoints of the segment, because that's what a perpendicular bisector is. So if I want to go to make an equidistant from each one, I want to go the same distance in each part. So I take my point of my compass and put it on A, and then I open my compass more than halfway. It has to be at least past halfway. It's got to be more than halfway. And you just draw an arc, like a half circle. I call it a football, is actually what we're going to do. We're going to make an arc like this. Now, I want to take the same compass, and don't move it, put it on B, and do exactly the same thing. So I'm going to create like a football. Well, let me see if I can do that a little better. All right, let me move this over here a little bit without changing the width. There we go. All right, and then I want to draw it like this. And I have created, it looks kind of like a football. Now, remember that when you have a perpendicular bisector, the segment is equidistant. Each point is equidistant from A and B. So it intersects here and here. So we want to line up our ruler and draw a line that goes through those two x's. And that is my perpendicular bisector. So it's perpendicular here, and it bisects right there. So my segment is perpendicular. I'll call this CD. CD is perpendicular to AB. That's perpendicular, and it's perpendicular at M, and M is the midpoint of AB. So when the perpendicular bisector is drawn, that will also help you find the midpoint of the segment. So you can do a construction to find the midpoint of the segment. So constructing the perpendicular bisector of the segment is the third basic construction. The next construction we're going to do is bisecting an angle. We're going to bisect angle A. So we know that the angle bisector will divide this angle into two congruent angles. Each point on the bisector has got to be equidistant from each side of the angle. So what I'm going to do is I have to measure this angle. So remember how when we copied the angle, to measure the angle, we take our compass, put it on the point, and then open your compass so that somewhere on here so that you can draw an arc that touches both sides of the ray. So it looks like this. And then we have to measure how wide this is. So you take your compass, put it on one point, open it to the other point right there. Now, what we did is measured that distance. Now, we want each point on the on the angle bisector to be the same distance away from each side. So leave the point of your compass on one point, but move the pencil out to the rest of it without changing the width. This was at 114 right there. So my width is still the same. Make sure your point is right on there and your width is still the same. All right, and then you draw a little arc. There's your little arc. Then you move your compass to the other point and do exactly the same thing. This is much easier with a regular compass than on here, but you can see what I'm doing. 114, there we go. My width is exactly the same. I haven't changed the width, and I've created an X. So you can see my X right there. If I connect the vertex to that X, I have created the angle bisector of angle A. So that means that this angle and this angle are now congruent. So this is bisecting angle A. All right, so I'll call this B. I can say that ray AB that I just constructed bisects angle A. That is the fourth basic construction. The next basic construction we need to do is to construct a perpendicular to a line L from point P not on the line. So this time, we want to construct a perpendicular, so we want to do the football one like we did before. But the problem is we need 2 points to work from here. Well, remember, a perpendicular bisector is equidistant from the endpoints of each of the segments. So what I need to do is be able to have 2 points to work from. So I'm going to take my compass, put it on P, and I'm going to open my compass enough to go past here, and I'm going to make like a U. It just has to touch the line in 2 different places. Once you get the 2 different places, you do the football like you did on the one for the perpendicular bisector. You put the point of your compass on one endpoint, open more than one halfway, and then do the football. So do the football, and then put the point on the other one, the other place of intersection right there, and do the same football. Let me open the same way. There we go. Same width. There. Same width, 193. There we go. Okay. And then draw your football. So there's your football. Kind of looks like a fish. And if you connect the X's here to here, if you did it correctly, it should go right through P. Oh, I'm off a little bit, so I can draw that a little better. There. Off just a smidge when I draw this. There, that's better. Okay, so use your ruler, line up your X's, use your ruler to draw it through, and it equals P. All right, and that is the perpendicular from there. So that is constructing a perpendicular to line L from point P not on the line. We can also construct a perpendicular to line L at a given point P that is on the line. This time we still need 2 marks on either side. Now remember, the 2 marks have to be equidistant from P. So if we put a point of our compass on P and open it up to some distance, it doesn't matter. I can put a distance here. And if I flip it around and do it on the other side, same distance, I now have my 2 points to do my football. So I can do my football, put the point of the compass here, open more than halfway, swing your arc, flip it over, do the same thing on the other side without changing the width. Don't change the width, just make sure it's more than halfway the same distance. And when you draw your line, line up your X's, it should go right through P. Well, that doesn't, but let's see if I can draw that a little better. All right, so here's my X, here's my other X, line up your X's, and it should go right through P. Whoops, that's off just a smidge. Like I said, it's a little different on here when you do these, but you can see when you line up the X's, it should go right through P. I'm off just a little bit right here, but make sure your lines line up. So that is when your perpendicular's on the line. So when you have perpendiculars, you need 2 points to do the football. So if the point is either on or off the line, you have to create your own hatch marks. The last basic construction is constructing a parallel to a line through a point not on the line. So if I want to construct a parallel line, I need a transversal. So the first thing I'm going to do is draw myself a transversal. Use your ruler, draw a transversal that goes through P. Make it long. Now, we're going to use the fact that corresponding angles are congruent in order to draw the parallel line. So, if lines are corresponding angles are congruent, lines are parallel. So I'm going to copy this angle up here. So take my compass, copy the angle. I'm going to draw my arc here, move it up here, draw exactly the same arc. Don't change your compass reading. There's my exact same arc. Those match. Now, I need to know how far the angle opens. So if I measure from here, open to here, measure there, and then measure the same distance up here. We do exactly the same thing because we want these to correspond. Now, since corresponding angles are congruent, if I connect this P to right here, a line through P, through the X, I have created corresponding angles. So these are the basic constructions you're going to have to know. I'll tell you about a website that has little applets to help you figure these out as well. So These are the basic constructions that you are going to need to know, and they are the basis of the other constructions we are going to do.